Okay, so welcome to you all students. Very good evening. This is going to be a very brief seminar on introduction to GIS and remote sensing and its application. Uh, by the way, we have got a few number of slides, that is 60 to be precise. So, and the time I have been allotted is 45 minutes. So I'll request you all to please pay attention for at least 45 minutes. I know that it's been a long day, and in the evening nobody likes to hear something or like go through a seminar, but yeah, please bear with me for 45 minutes. It's going to be very fast session, and we'll keep it interactive. And if you have any doubts or any questions, please note it down. We'll be answering to each and every one of you at the end of this webinar. We'll be having a fixed time slot, that is 15 minutes for the your answers and any doubts you have on any of the topic. So let's begin with the content, that what it is all about. So first of all, I've been told that you guys are from civil engineering department. So most of you, I think, must be somewhat like aware about this. What is this technology all about, GIS and remote sensing? But to because it's a initial session on what is GIS and remote sensing, I'll be starting it from the scratch for all of you. So to start with the content, uh, we'll be doing what is GIS, how it is helping us, the file formats which are being used in the GIS, spatial data and non-spatial data formats, the coordinate system, and how do we collect the data, applications, software used. Now the world is moving very fast, so it's all about the development. So WebGIS is an important part, so we'll be discussing a bit about that. And then your how do we shape your future in your career in a professional way. We'll be in looking about that too. And finally, a GS concept that I would be explaining into a bit of detail, that is going to be remote sensing. Okay, so let's start with it. So basically, what is GIS? As the name suggests, GIS is about geographical information system. Now, don't go with the definition, because the definition might confuse you all about. But it's a geographical information system is all about a multi-component environment which is used to create, manage, visualize, analyze spatial data counterpart. So most of you would be wondering what he's saying. So let's look into the next slide, how GIS is working actually. So GIS is all about just a second. Okay. So GIS, as the name suggests, it's a geographical information system. So first of all, what is geography? Geography is all about the study of what are the features on Earth, study of temperature, population, and vegetation, natural resources, and everything. Whatever the features are on Earth, it's a study about that. Geography, right? And what information is associated with it? So by mixing both of them, it is known as GIS, and it's an upcoming technology which is being used, I would say, in almost all the fields I've been working. Like you just name that field and GIS must be there. Right. Starting from the applications of defense till the insurance department, till the post office, logistics, everywhere the GIS is being used. So those guys are actually dealing with the geography of the earth, right? And along with it, the information is needed. Now, what is this information is all about? It's integrated data, like street data, vegetation data, building data. So because most of you are from civil engineering department, you have been working with, I think, AutoCAD drawings. So AutoCAD drawings are having the layers of floor plans are there, doors, windows, electrical features, and then many such data sets are there. So you are working on a particular building, but here I'm talking about the geography. The geography means earth surface, so it can have some parcel boundaries, as you can see on top. Parcel means uh, building footprints, building blocks. Okay. Zoning, how the zoning is being done, board maps. Okay. Topology, like how much is the elevation area, wetlands, demographics, land cover, land use, and satellite imagery. Okay, so this is what information is attached. This is just an example. Okay, so likewise, many such information can be attached. We'll just see it in the coming slides. So it explains about what exists at a certain location. Like if you want to Google all about like where is the nearest restaurant to me. Okay, so what do? You go into the Google Maps and you search restaurant near me, or maybe if you're looking for a education institute near you. So it's all about the GIS. So the process which is working in the background is GIS, right? Where are the certain conditions satisfied? So if I'll say that I want to create factory, so what are the conditions satisfying? Will you go into the field searching about the factory? No, you would definitely not. That is a more of a traditional approach. But nowadays, because we are into the GIS, so we actually look at in a spatial manner. Spatial means anything recorded from the space. So I think I'll be using this term spatial every now and then. So just to explain you guys, spatial means whatever which is being recorded or which is being viewed from the space is known as spatial. As simple as that. I hope I'm making sense to you guys. Okay. So where are certain conditions satisfied? So as I told that if I want to set up a factory, I'll be looking at a different layers like land use layer, land cover layer, okay, and master plan of the city, and I think soil data as well. I would be looking where the soil is sandy, where the soil is loamy, according to it, and I think I would be situating my factory at a certain um, I would say high elevation area because it should not be drained into when the flood is there or when some calamity is there, right? So how do you do all this analysis? This is the GIS. Okay, what has changed in a place over time? Like I would give an example: vegetation. Okay, so how the vegetation was like in a particular area 10 years ago and how it has changed right now. You can also take an example of landslide. Okay, so this is the time when the landslides are happening in the Himalayan area. So what researchers do, what scientists do, they actually look how much the landslide has happened. So previously how much the land was there and right now how much the land is there. So they actually do the volumetric analysis according to that, and they estimate that this is the landslide which has happened at this point and this much is the volume of the debris, right? What kind of spatial pattern exists, like again I would say road network. Okay, so it is actually the information on the world, like I already explained it to you, how it looks, forms, the patterns, what is the process is all about. So it is the science behind that. So it's a technology which is all about finding things and analyzing them on the surface of the earth, and you can do many sorts of models into that. We'll be looking at the applications afterwards. Okay, so for the time being, it's a technology which is combining the geographical features with the information system, and then it analyzes with different algorithms, I would say. Okay, again an example is there. So finding your location on Google Maps or maybe your Amazon delivery logistics, they all work with the GIS. Okay, without GIS, they cannot do. The army surveillance, the defense surveillance, it all happens with the help of GIS technology. Okay, the urban sprawl in a city or in a village, it is being monitored with the help of GIS. So basically, the GIS is the science of where, right? Where is this that question which arises in your mind are being answered with the help of GIS. Of course, you need to be skilled to do such sort of analysis. You need to do various tools and techniques are there. But for right now, just keep this in mind that GIS is the science of where. What is this? This is a I would say that just note down your questions and we would be answering that afterwards. Okay. Yeah, someone is saying globe, someone is saying globe map by Google, Earth, latitude and longitude. My God, you are very much ahead of the time. Okay. So yeah, this is the surface of the Earth. This is taken by the Google Maps. What is the shape of the Earth? Does anyone know? It's an ellipsoid. Okay. So how GIS is helping? For an urban planner, GS is helping that how the growth of the city would be like in coming years. So how they are actually developing the master plan. If anyone of you has seen the master plan of any city, so master plans are being built for coming 10 years or 20 years, so maybe 30 years for some cities. So how are they being made? They actually calculate the past trends, or from the past analysis they figure out that how the urban sprawl is going to be, how the vegetation and how different zones are growing up in the coming years, how the highways going to be planned. Okay, so along that they actually design the master plan for a city, and that master plan, that study is being done with the help of GIS. Then an environmental scientist would be assessing that how an impact has happened after a natural hazard. A geologist would be identifying that what is the best suitable site for his mining exploration areas. Okay, so while you are actually maybe purchasing a mines, not purchasing right now, maybe it's an auction of mines. Okay, so when the government asks you to auction your mines, so the mines owner who come there and they sanction the plans. So site suitability analysis has to be done for that, and some old analysis has to be done. And to explain you it in the simple things, simple way, um, a mining area should not be near to the forest area, right? It should not be near to the a river body, okay, or it should not be near to the wetland. So there's a particular place where a mine should be located. Of course, it should be in an area where the minerals are there, but along with it, certain other rules and regulation has to be followed, just like your building bylaws, right? So all those overlay analysis and proximity analysis are being done with the help of GS. Okay, so a civil engineer would be selecting a site best suitable for his upcoming dam project. Maybe it's an earthen dam, or what do we say? It's some different sorts of dams are there. Okay, so how would he plan it? How would he look about it? Right? Soil analysis has to be done. Okay, and highland areas has to be planned. Any villages coming nearby or not, any proximity analysis has to be done. So any like vegetation area is not coming now, so otherwise it would just deteriorate their I would say field crop fields. Okay, so various aspects are there. Then a geoinformatics engineer can help a mobile company to set up their mobile tower location based on various factors, so that it can help them to reduce the costing, land prices, and along with it, different aspects are there. Okay, and then a forest officer would be helping how the tree canopies are there, how not a forest officer, but maybe a geologist or maybe an environmental engineer would be doing that. That how tree canopy and the forest canopy has increased or decreased with the duration of time. The hydrological engineer would be identifying the water quality parameters of different sizes. So previously, I was doing a project which was based on identifying the um, different locations, well locations, that from there we were identifying the water samples, and along with that water samples we were identifying that what all health impacts it is having on the nearby people, on the people which are living in the proximity of there. Okay, so along with it, it was identified that the few wells were not of good quality, or maybe it was much more polluted, the water was much more polluted. So that all study was being done with the help of GIS. So we created maps out of it. Okay, so with that help of the map, the local government identified, okay, these are some critical wells, so we have to either remove it or maybe we have to improve the quality of the water. So in the future, coming days, it won't be as much as polluted, and also it should not affect the health of the people living there. Okay, so such sort of studies are there. So as I already told you guys, that is going to be everywhere. GIS is going to be everywhere. Like a friend of mine, he's working in an insurance company, so that insurance company is actually analyzing that how uh, the people are actually buying their insurance, and from which city they are actually buying more, and from which city they are not buying, and then certain other aspects, that what are their health conditions, what are their income level, and how much age they are of. So along with it, they actually introduce new plans. Okay, so basically it's all about the information system which is related to the geography of the earth. Okay, so you might have heard about the data science. So data science is an upcoming field. So GIS, I would say, is one step ahead of the data science. It's called spatial data science. So it's the data science of the space. So if you are into GIS, you are going to deal with a lot of data, but it's going to be the geographical data. Okay, so geographical data is the spatial data. Okay, so file formats. This is I would just brief on you it because it's very important, but it's a bit of boring as well. So file formats. Uh, b- Basically, when you store the data, they are basically stored in some sort of file, like you store your AutoCAD files. So it's a .dwg format. So likewise, we also store our data, which are of two types: vector and raster. What is vector? What is raster? That we would be extending. That I would be explaining you in the upcoming slides. But just to brief you out, guys, that this sort of data extensions are there. .mxt is there, .qgis is there. So it actually depends on the different softwares. Okay, so vector file formats are saved into this .shp. .shp is the most common uh, extension which I think you guys would be using if you're into GIS. That is shapefile. So the name suggests it's a shape and it's a file extension. Okay. .dwg, I think most of you would be knowing. .okmz, if you export any file from the Google Earth, okay, it would be saved into a KMZ format. Again, it's a geospatial extension. Then GPS data is there. Then raster files are there, and different database files and formats are there. Okay. So spatial and non-spatial data. So I was clearly again and again mentioning what is spatial data, what is actually it is. So just to make you understand, guys, bit better. Uh, if I'm going really fast, I think you guys can mention it. I think we should study the non-spatial data first because I think you guys can relate a bit better with this. Okay, so this is a non-spatial data. I think you guys have worked on the Excel, Microsoft Excel, or maybe some other information software. So how do you store your data? You store in your data in the rows and columns with the help of an ID or with the help of a serial number, right? So like you can see, this is my name, this is my age, and this is my gender. Then it can be my mobile number, then it can be my address, then other information like where I'm working. So such information can come. So this sort of data is known as non-spatial data. Why non-spatial data? Because there's no location attached to it, right? I mean, the address is located, but it's not in a spatial format. Okay, you cannot just see that address and you can reach up to me. No, you cannot. You will have to be really smart to do that. Okay, so this is the spatial data. Now, how do you place mark your things on the Google Maps, or maybe how do you find your nearest cafeteria, a coffee shop nearby you? You just write the name, and then what Google Maps gives you? It gives you a place mark, and that place mark, if you'll see it very closely, it would give you a latitude and longitude. Now, what is latitude and longitude? Latitude are some. I would go on to the previous slides and I would explain to you. Okay, so the line which you are seeing in the center of the earth, this is known as equator. Okay, so the lines which are running or parallel to it are known as latitudes, like this way. Okay, or parallel to it. And the line which are running from north pole to south pole, they are going to be longitude. Okay, so it's a great format. So that's how the address matching system works. Okay, it gives you the some values which is based on the latitude and longitudes. Okay, so it's basically stored in the x and y format, because just to not name it again and again, that latitude and longitude, it's easier that x and y coordinates we can say. Okay, so if any location attribute is attached to a non-spatial data, it automatically becomes the spatial data, because now you can actually place it. Okay, so the points which you are seeing here, okay, so those are the locations. Those are the locations of any person or a building or maybe a garage or a hospital, whatever it can be. Okay, so it has got a location attribute attached to it. Then it can have some other attributes as well, that what sort of hospital it is, whether it is a heart hospital or is it a maybe some other hospital. Okay, and what sort of doctors are there, what facilities are there, how many floors it has got. So certain different information is attached to it. So again, location plus information, that means GIS, geography plus information. That is all about is GIS. Okay. Then why are we actually collecting those informations? That is the beauty about the GIS. You query your data on AutoCAD? You cannot. Do you use the proximity analysis, or do you make some sort of maps like which can be easily readable to any layman on AutoCAD? It's not. It's not. It's not mean to be like that. Okay. So this is the beauty about GIS, that you can actually integrate different layers, like AutoCAD layer is there, satellite imagery is there, and then locations like this points are there, and then you can merge everything together, and then you can query it, and you can also use different sort of geoprocessing tools, that how it would give certain information to us which can be useful. Okay, I hope I'm making some sense to you guys. Okay, so now, spatial versus non-spatial data. Why do we use spatial data and why do we not use the non-spatial data? Basically, spatial data is also of two types. One is attribute data and one is spatial data. So just not to go into the deep too much, because this is just an introductory session. So spatial data is a uh, I already mentioned you. Now this non-spatial data, why are we not using it in GIS, especially because it is not giving us any sort of valuable information which we can do some sort of analysis, like collecting how many people are living in a particular ward. Like right now, a pandemic is going on. So if you know, the Indian government or the state governments, they are using it up to a much greater extent for the COVID scenario. So they are defining the red zones, they are defining the green zones, and then they are defining the orange zones, where the proximity of a disease is there. So they are actually announcing that this is a very critical area, or this is the hotspot area of cases of this COVID-19. So according to it, we would be imposing a lockdown here, and rest all the areas can work normally. So how they actually plan it, how they actually do it with the help of the spatial data. That's why they are not using the non-spatial data, because non-spatial data is all about the rows and columns, which is bit meaningful, but actually in analyzing it is meaningless for them, because it is going to be inside some sort of tables and books or traditional maps. So you cannot actually analyze through it, right? So like I already mentioned, you can do some sort of geoprocessing analysis, like overlay analysis, and then finding nearest destination, shortest route, creating watershed. Such sort of applications are really meaningful to a layman or to a normal human being. Like applications are immense. Okay, applications are like you can estimate the moisture of a soil, you can find out where the particular mineral is. So the applications are immense, but because you guys are very much new to the GIS field or the geospatial field, I am only giving you the few examples which are very easy to learn, or which are very easy to remember. Okay, so let's discuss this thing. What is data format in a GIS? This is going to be very important. So please pay attention to it. So there are two sorts of data. One is raster data and one is vector data. So what do you mean with the raster data and vector data? Raster data is made up with the pixels, and the vector data is made up with the lines, points, and polygons. Okay. Now, even if you guys are not understanding, I will give you a very clear example, that if you open the Google Maps, okay, and if you are onto the offline map, what it shows you? It shows you a line in the form of a highway. It shows you a polygon in the format of a building, and it will show some points, which will be some shop or maybe some nearby location. So what is that? I'm sorry. What is that? Point, line, and polygon. And when you switch it to the imagery format, it gives you a picture. And when you zoom in, zoom in, you start seeing that this image is getting distorted. So it is made up of some pixels, like your photograph is there. You take out your mobile phone and you click a picture. It is made up of some pixels. If you zoom it very much, it will start getting distorted. So what it is made up of? It is made up of some pixels. Okay. So I think I was pretty much clear in this, that what is raster and what is vector. Okay. If any questions are there, you can just save it for the later time. Okay, so raster data is, so as we say in our GIS community, raster is faster. Why? Because it's a continuous data. Continuous data means it's a data about the surface. Because the satellite imagery which you open in the Google Maps, it is a continuous imagery. Okay, so somewhere you actually see the building, somewhere you actually see the crop fields, then you see some water body. So it's a picture, and a picture is definitely a continuous form of a data. So any data which is continuous is going to be faster, right? And this is how the data is being stored. So if you can see this imagery, this is a satellite imagery of maybe South India. Okay, and if we click onto a particular value or maybe a point on the imagery, it would show us some values. So a raster data is made up of some values. Not to bore you guys, but these are known as DN values. Okay. Now, vector data, as I already mentioned, it is made up of point, lines, and polygons. Okay. If raster is faster, but vector are correcter. Why? Because we can do analysis on with it. We can also do analysis with the raster data, but the data which we are having in front of our eyes, that is polygon line and point, that can actually work as an entity, and it can actually give us some meaningful information. So suppose this line is a highway, okay, and this area is a water body. Okay, so you can do some sort of analysis, right? That where the next bridge is going to come, or where the new maybe cafeteria near this pond can come, by seeing different aspects. Okay, so vector are correct. Now you guys must have seen the GPS devices. If not the GPS devices, there's an app inbuilt, or maybe you can download it from the Play Store, or maybe from the iOS store in your mobile phones. GPS information. So what does that GPS information do for us? That GPS collector collects the point data. Okay, that point data is being acquired with the help of some satellite. So you can analyze according to it. And then if you are going for a cycle ride, a bicycle ride, or if you're going for a run, and if you're wearing a smartwatch into your hand, it will actually collect the line data, point wise line data. So basically it is very much useful for us to do some sort of analysis. How that we can do it, we'll look in the further slides. But for the time being, you just understand that what is spatial data, sorry, what is vector data and what is raster data. Okay. Now satellite imagery. Now, what is the concept of pixels? As I already mentioned in the remotely sensed data. What is remotely sensed data? This big word. I think it can confuse you guys. So don't worry about it. We'll be looking it afterwards in the GS concept note, that what is remote sensing. But right now, uh, any imagery which is being covered from satellite imagery. For the timing, you just take this example. From a satellite, picture has been taken, that is called as remotely sensed data. Now the concept of pixel, what that pixel actually denotes, that pixel will give us some values, and that values can be of numeric, it can be integer, it can be a character, it can be anything based on the sensor of the satellite, based on the application which for which the satellite has been sent to into the space. Okay, it can be for your communication devices, mobile phones, it can be for your army surveillance, it can be for monitoring your vegetation index. I mean, the how much the canopy of the trees, or how much uh, uh, crop field is there, wasteland is there, likewise fallow land is there. Okay, so there are different applications. So according to the different applications, different satellite are being sent into the space, and different satellites are having different sensors, and they actually record the satellite imagery. Okay, this is a simple process. You don't need to go into the deep, but this is a simple process. Likewise, you click a camera picture from your mobile phone. It's a It's a sensor only. Okay, and in that the resolutions are there. So what is mean by resolution? Like you say that my mobile phone is of 40 megapixels, 60 megapixels. Okay, so what is that pixel is? The pixel actually denotes the area of the point, right? Now you will understand better in this next in this imagery.